Ohio isn't exactly famous for endless sun-drenched days. Between the humid summers, the freezing winters, and a whole lot of clouds in between, you have to wonder, can solar panels actually work here? When we picture solar power, we imagine blistering, cloudless deserts. But the reality of a typical Midwestern suburb looks quite different. It is incredibly easy to look out your window during a gloomy, gray week in January and assume there is no way a roof full of panels could possibly pay for itself. But treating residential solar like a day trading game, where daily weather dictates your success, completely misses how the technology operates. A properly sized system is not built around tomorrow's forecast. It is a year-round investment vehicle. To understand how a home powers itself through the changing seasons, we have to stop obsessing over daily cloud cover and start looking at the annual environmental math. The best way to make sense of that math is to start big and look straight up. We have to analyze the macro level, the sky overhead, to see the physics of energy production in action. The biggest hurdle on everyone's mind is the sheer volume of prolonged cloud cover a state like Ohio gets. Obviously, panels operate at peak efficiency under clear, blue skies, when they can soak up strong, direct sunlight. But look at this diagram showing how light travels. Even when the sky turns overcast, solar panels capture something called diffuse sunlight. As light particles hit a thick cloud layer, they scatter and reflect through the atmosphere, meaning a significant amount of solar radiation is still actively striking the panel below. Then there is the assumption about temperature, the idea that solar panels need physical heat to function. As we zoom in on the panel surface here, notice what happens when the thermometer drops. Solar hardware converts light, not heat. And from a pure engineering standpoint, cold air actually cools the internal circuitry, increasing the operational efficiency of the entire system. This creates an interesting paradox during the summer. High heat on the roof actually decreases the panel's efficiency slightly, but the massive increase in total daylight hours easily overpowers that minor loss. When you map out the sky over a full calendar year, the volume of daylight hours dictates your output far more than the ambient temperature ever will. Of course, those daylight hours eventually shrink, bringing us to the hardest variable for Ohio solar: winter. In this profile view, you can see the dual threat of the season. Not only do you have fewer total daylight hours, but the sun's trajectory drops significantly lower toward the horizon, casting a much narrower angle of light across the roof. And if you add a winter storm into the mix, a physical barrier forms. When panels are completely buried under a heavy blanket of snow, their electrical output drops to near zero. Fortunately, panels are installed at an angle and built with incredibly smooth glass. Once the sun comes out, the dark surface warming up, and that heavy slab of snow slides cleanly off, allowing production to resume. Winter snow is a temporary physical pause, not a fatal flaw. Because solar planners measure performance over 365 days, the immense overproduction of the long summer months mathematically subsidizes the deficit of a snowy February. While we cannot control the sky, we have complete control over the microenvironment directly beneath it, the home itself. Weather changes daily, but roof geometry is permanent. This is exactly why two houses sitting in the same neighborhood, experiencing the exact same weather, can generate wildly different amounts of electricity. Looking at a top-down blueprint of a property, the directional orientation dictates everything. The sun's path naturally lights up the south-facing plains for optimal production, though east and west-facing sections are highly viable depending on the layout. Shifting to a ground-level profile, we also have to factor in the pitch. The steepness of the shingles determines how directly the panels catch those incoming rays throughout the day. But even perfect angles can be ruined by physical obstructions. Chimneys, dormers, and mature trees cast moving shadows across the roofline, severely reducing your total energy yield. A regular cloudy day is not what sinks a solar investment. The real threat is a cloudy day combined with permanent, inescapable roof shade. The true limit on your home's power production isn't the Ohio climate. It is a poorly analyzed roof. This heavy reliance on unique architecture is why generic online solar calculators give a misleading picture. As you can see on this interface, an internet algorithm cannot accurately calculate missing variables like tree shade, dormer placement, or your specific microclimate. A website also cannot inspect the physical age and structural integrity of your shingles, which is a required step before bolting down hardware meant to last for decades. The only reliable way to know if the math works for your home is to get a property-specific assessment, one that sizes the system based entirely on your actual energy usage and your unique local geometry. For homeowners in Sunbury, Ohio, the next step is simple. You can have Solar Panels Sunbury conduct this exact property-specific evaluation to see the real numbers for yourself. You cannot control the Ohio weather, but by engineering a system around the precise realities of your roof, you take complete control of the results.